Okay, we took this assessment in class, and I'm going to go over it step by step for those of you who are struggling. Number 1, the sum of x squared and 11x is negative 30. The first thing you have to understand is sum means we're going to add. And it says the sum of x squared and 11x. So we're going to add x squared and we're going to add 11x. And the sum of these two things is negative 30. Well, is in math means equals. So the sum of those two terms is negative 30. Now, if we are going to solve this by factoring, the first thing we have to do is get it in standard form. So I'm going to add 30 to both sides. And when I do that, I get 0 here. And on this side, I get x squared plus 11x plus 30 equals 0. So I got it in standard form, and I made y equals 0, which is step 2. 1, standard form. 2, y equals 0. Okay, third step is to factor it. And when I factor it, I'm going to do it like I always do. GCF, special cases. Special cases would be PST or dots, difference of two squares. If it's a perfect square trinomial, I do a binomial squared. If it's difference of two squares, I do sum and difference. Okay, if it's not a special case, if the leading coefficient does not equal 1, I use extra x-man. If the leading coefficient, which is the a term, does equal 1, then I use plain old x-man. So, standard form, y is 0. GCF, no. These do not contain any of the same factors other than 1. Special cases, it's not a PST, this is not a square number. It's not dots because it's not a binomial. It's not the difference of two squares, it's a trinomial. So, a is equal to 1, my leading coefficient is 1, so I'm going to use x-man. A times c is 30, and b is 11. And the way I'm going to get 30 is 6 and 5, and 6 and 5 is 11, but that has to be negative 11. So if I make both of these negative, their product is positive 30, and their sum is negative 11. So my two factors are x minus 6 and x minus 5. And x minus 5, and that still equals 0. These two binomials just replaced this trinomial because they're equivalent. I just factored this to get this. If I multiplied these back together, I would get my trinomial back. Now, I'm not done, because the next thing I have to do is set each factor containing a variable equal to 0. Well, I have two factors here. This is a factor, and this is a factor, and they both contain a variable. So I'm going to take the first one, and I'm going to make it equal to 0. I'm setting each factor containing a variable equal to 0. This is a factor, it contains a variable, make it equal to 0. I'm still not done. I have to solve for x by isolating my variable. So the way I do that, in order to get x alone, I have to get rid of negative 6. So I'm going to add 6 to both sides. X equals 6. And for this one, I'm going to add 5 to both sides. X equals 5. These are my solutions. That means that this particular quadratic has two roots, has two solutions, it has two roots, it has two x-intercepts, and it has two zeros. And guess what? If I graphed this same equation, I would get x-intercepts of 6 and 5. There's 5 different ways that I'm going to show you how to solve a quadratic, and every answer should give you, or every every way you use to solve it should give you the same answer, unless for some reason it doesn't work on that quadratic. All right, number 2. The sum of x squared and x is 56. The sum of x squared and x is 56. Again, sum means plus. What are we adding together? X squared and x, and the sum of those two terms is 56. It's a quadratic because the highest exponent is a 2. So I know it's a quadratic. If I graph it, it's a parabola. But if I want to solve it by factoring, I have to put it in standard form. So I'm going to subtract 56 from both sides, and I'm going to get x squared plus x plus minus 56 equals 0. So I have the added bonus of having it in standard form, and my y term is equal to 0. So that's step 1 and step 2. Step 3 is to factor. Well, I don't see a GCF. It's not a PST. It's not dots. The leading coefficient is 1, so I'm going to use plain old X-man. A times C is negative 56, and B is 1. Well, I know that 7 times 8 is 56, and those are 1 apart, so that should work. If this is going to be negative, one of these has to be negative. Well, I'm going to have a positive left over. I need more positives than negatives, so I'm going to do this. Their product is negative 56. Their sum is positive 1. So my two factors are x minus 7 times x plus 8 equals 0. This is equal to this. Therefore, this still equals 0. Now I'm going to set each factor containing a variable equal to 0. That's the 0 product property. So x minus 7 equals 0. X plus 8 equals 0. Add 7. X equals 7. Subtract 8. X equals negative 8. These are my two x-intercepts. And honestly, if you want to verify that, if you're looking for x-intercepts, then these values of x should make y equal to 0. Well, let's plug them into our equation. If x is 7, then this is going to be 49 plus 7 minus 56 equals 0. Well, this is 56 minus 56 equals 0. 0 equals 0. When x is 7, y is 0. So that is, in fact, an x-intercept, because when x is 7, y is 0. That's right on my x-axis, isn't it? Now let's plug in negative 8 and see what happens. Our other solution. Okay, if I take negative 8 and I square all of it, and then I add a negative 8, and then I subtract 56, well, let's see. Negative 8 quantity squared is positive 64. This is combining that with a negative 8, and combining that with a negative 56. If I combine all my negatives, I get 64 negatives, and combine with 64 positives. Those cancel out. Y is 0. There's my other x-intercept, because at this point, when it's touching the x-axis, y is 0. So there's my two solutions. And those values of x